Now in class 9th ISC pattern, I am taking the numerical based on the density and the relative density. Always remember that relative density of the material is always found with respect to the density of the water at 4 degrees Celsius, which is a standard temperature at which the density is maximum, which is to be now 1 gram per centimeter cube, or this is 1000 kilogram per meter cube. So now I take the numerical question. Now see here. There are so many numericals based on this density so much. Now the first question is the density of copper is density of copper is 8.83 gram per centimeter cube, express 18 kilogram per meter cube. Express it in kilogram per meter cube. So now solution. This is given now density D equal to 8.83 gram per centimeter cube. So this 8.83 and this is now your 1000 kilogram per meter cube. So this is expressed in terms of if you multiply to this one, then this is 8830, so much kilogram per meter cube. This is the answer. Now question number 2. The relative density of mercury is so much. Relative density of mercury is 13.6. State its density in number 1 the CGS units and number 2 SI units. So now the solution to this one is that in CGS density this is now first answer. This is your 13.6 and the density of water is always equal to, that is now 1. So this is so much gram per centimeter cube. And then to express this in terms of SI unit. SI units. Now then this density D equal to 13.6 into 10 raised to the power minus 3. 10 raised to the power 3. Kilogram per meter cube. So this is to be expressed in this way. This is now question number 2. And now question number 3. Now 3 is the density of iron is so much. Density of iron that is equal to 7.8 into 10 raised to the power 3 kilogram per meter cube. What is its relative density? What is its relative density? This is our question. So now its solution will be solution. Now relative density equal to RD equal to this density of iron upon density of water at 4 degrees Celsius. So this is now given your 7.8 into 10 raised to the power 3, and this is now your 10 raised to the power 3. So this RD equal to 7.8. This is now so. This is the answer. This is the answer. And now question number 4. That is the relative density of silver is so much. The relative density of silver is 10.8. 10.8. Find its density. Find its density. Now solution. Relative density equal to density of silver upon density of water at 4 degrees Celsius. So now this RD is 10.8. This is equal to now density of silver upon density of this one. This is suppose you are given in NKS or this no CS, then you can write it to this one 10 raised to the power 3. Therefore density of silver is equal to 10.8 into 10 raised to the power 3 kilogram per meter cube. This is the answer. This is now 4th question. And now your 5th question. Question number 5. Question number 5. Calculate the mass of the body. Calculate the mass of a body whose volume is 2 meter cube, and relative density is that is 0.52. This is not so much. Now solution to this is that you are given the mass, you have to find the mass, volume is given, relative density is here, so density of the body, equal to RD into density of water at 4 degrees Celsius. So now this is all given in kilograms. So RD is 0.52 into 10 raised to the power 3. So much is kilogram per meter cube. Now you are given that volume, so mass of body, M equal to D into V. So now this is now your D, 0.52 into 10 raised to the power 3 into, now volume is 2, this is now volume 2. So this is now your 1.04 into 10 raised to the power 3. So this is 1040. So much kilograms. And this is the answer to this question. Now question number 6. Question number 6 is a body of volume 100 centimeter. Volume of 100 centimeter cube weighs 1 kg in air. Weighs 1 kilogram force in air. Then this is given, find its weight in water. Find its weight in water. This is now first its weight in water, and given the this is now question number 6. No. This is not. Question number 6, this is not. Calculate mass of air. Mass of air. In a room, of dimensions 4.5 meter into 3.5 meter into 2.5 meter. If density of air at NTB is 1.3 kilogram per meter cube. So now answer to this question is You are given the volume, you are given the density, then just to find the mass N equal to D into V. Now D is 1.3 and V is your 4.5 into 3.5 into 2.5. So much. And that will come out to be 11.51.19. So much closer. And this is the answer to this question. Now question number your 7. A piece of mass uh, 113 gram 6 to the bottom. Bottom in water contained in a measuring cylinder and water level in cylinder rises and water level in cylinder rises from 30 ml to 40 ml. Calculate RD of stone. Calculate RD of stone. Now solution. Now you have given the mass of this stone and the weight of the volume of the water. So you are given water is to be, now this is given to be now 1 RD. Weight of stone in air W1. This is now 1 point. This is now so much grams, and that upthrust U is equal to W1 minus W2. So this upthrust is equal to that the volume V L rho L into G. So this VL is equal to your 40 minus 30. Density of liquid, that is now water, is equal to 1. This is now water. Rho L equal to 1. So this we are taking. This is now you 10. This is now equal to so much. It's a ground force. Now then relative density equal to W1 upon U. So this gives the RD equal to 1113 upon 10, or this RD equal to 11.3. This is the answer to this question. And now question number 8. A body of mass 100 centimeter cube of volume 100 centimeter cube weighs 1 kilogram, weighs 1 kilogram force in air. Find its weight in water. First is given the find first its weight in water, and second its relative density R. So now first weight in water. Water equal to their volume is given here. This will be the volume of the liquid displaced or water displaced. So this is now your volume V, and the density of the water rho L. So V is equal to 100 and rho is given to be 1000. V is given to be 1000. Now this is now in cc, so this is now your 100. This is now 1. So this is now your 100. So much ground force. Now weight in air is given here. Given weight in air. This is equal to 1 kilogram force. 1 kilogram force. So this is equal to this is equal to 1000 gram force. Therefore, now weight in water. This is what the upthrust. This is now upthrust. Weight in water. This is question of thrust. This is upthrust. Upthrust. So, weight in water. This is now your 1000 minus 100, so this is equal to 900 gram force. This is our first answer. And now for second, we have to find the RD. RD equal to W1 upon U. So this is weight, this is given to you now, this is now your W1. This is now W1. This so much. So this is equal to 10,000 upon 1,000 upon. This is now your 100. Upthrust is 100. So this is now RD equal to 10. This is the answer to this question number 8. And then the question number 9. Question number 9. A body of mass 70 kg. A body of mass 70 kg. When completely immersed in water, when completely immersed in water, displaces 20,000 centimeter cube of water. Then find number 1, the weight of the body in water. Weight of body in water. And second, the relative density of the material of the body. Relative density of material of the body. This you have to find. Now then its solution. Since it displaces so much cubic volume of this water, and we know that the density of water is equal to 1, so that will give you now that upthrust will be how much? Upthrust. This is equal to, now volume is so much. Now this is now your V L into rho L. So this upthrust U is equal to, this is now VL is equal to your 20. And that the density, this is given to be so much, the density is given to be here. This is 8, 9. Now then this is Now 1, then this is your 20. This converting gram to kilogram, because you are given this 70 kg. So this is now your 20 kilogram. So much is the thrust. Then what we have to find? First we have to find the weight of the body in water. Weight of body in water. That is equal to W1 minus U. So W1 is equal to your 70 minus this is now your 20. So this is now your 50 kg. And then the relative density RD equal to the density of the body. So this is coming out to be your W1 upon U. W1, this is now your 70, and U, this is now your 20. This will cancel. So RD equal to 3.5. This is the answer. And this is one more answer. So these are the two answers of this question number 9. And then the question number 10. A solid body, a solid base, base 120 gram force in air, and 105 gram force, 105 gram force when it is completely immersed in water. Then asking that calculate the relative density of solid. Calculate RD of solid. Now solution. Now this RD equal to W1 upon W1 minus W2. So now this is equal to RD. This is now your 120 upon 120 minus 105. So this RD equal to 120 upon 120 minus 105, and that will give you 120 upon 15. This is not 15. So this will come out to be 8. This so much. This is the answer. Now question number 11. A solid weighs so much gram force. Weighs 32 gram force in air and 28.8 ground force, 28.8 ground force in water. Find the volume of solid. Find number one, volume of solid, and second, the RD of solid. RD of solid, and third, the weight of solid. Weight of solid in a liquid of density. Liquid of density 0.9 gram per centimeter cube. Here we are given the water and this is given the liquid also. So first we have to find the answer to this one. Answer to this one, 11. So let us find first is it is asking the volume of the solid. So upthrust, U equal to W1 minus W2. So this U equal to W1 is equal to 32 and this W2 is equal to 28.8, and this U will be how much? Volume of the solid into volume of the density of the liquid, so much, and this Vs we have to find. This is now equal to 1 and this will be your how much? 3.2. This is now your 3.2. So giving you this Vs equal to 3.2 centimeter cube. This is now first answer. And now second one, RD of solid. This is now your first. Second, RD equal to W1 minus W2 upon W1 upon W1 minus W2. So this RD equal to W1 is equal to 32. This is now your 3.2. So this RD equal to 10. This is the relative density of the solid. Now the weight of the solid in liquid of density so much. Weight of solids. Now the third part. Weight of solid. Now the volume you know. This volume is equal to Vs into the rho L. Vs is equal to your 3.2 and rho L is given to be 0.9. 0.9. So now 18 and this is now 27 and 28. This is now 2.88. This is so much is the weight. No, this is not upthrust. This is not upthrust. in liquid. So this is now U equal to so much. Therefore weight in liquid. Now this W2 equal to W1 minus U. Now from here, so this is given to you your 32 minus 32 point minus 3.2 into 0.9. This is now 2.88. So this is now your 29.12. So much gram force. This is the answer to this question. Now on question number 12. Question number 12. A body weighs 20 gram force in air and 18 gram force in water and 18 gram force in water. Calculate RD of the material of body. Calculate RD of the body. So now solution to this one is RD equal to W1 minus W2. So this is now your 20, this is now upon 20 minus 18. So this is now 20 upon 2. So this RD, this is equal to 10. This is the answer. So this is the question number 12, and that's the question number 13. Question number, this is 12, this is now 13, so the question number 13. Now question number 14. Question number 14. Now a jeweler claims that he makes the ornaments of pure gold of relative density 13.3. Given RD, density RD of pure gold is equal to 19.3, and that he sells the bangles weighing so much gram to a person. Weight of gold bangles in air, this is equal to 25.25. So much gram force. A clever customer weighs them in water, this is to be so much. Weight in water, this is given to be 23.075 gram force. Then this is asked with the help of suitable calculation. Find out whether the ornaments is made of pure gold or not. Then we have to find the RD of this one. RD of gold. W1 upon W1 minus W. So W1 is 25.25 upon, this is now your 25.25 minus 23.075. So this is coming out to be approximately 11.6. 11.6. And this RD is less than this one. It means that the bangles are not of pure gold. So RD of pure gold, RD measured is not equal to RD of pure gold. So bangles are not made of pure gold. Bangles are not made of pure gold. This is now question number 14, and now question number 15. You are given question number 15. That is the piece of the iron weighs so much gram in air. Weight of iron in air. This is W1. This is equal to how much? This is given to 44.5. So much gram force. If the density of iron is so much, density of iron, D, this is equal to 8.9 10 raised to the power 3 kilogram per meter cube. Now you have to find so much, find the weight of the iron piece when immersed in water. Weight of iron piece in water. This we have to find. So now what we have, the density is given to be so much, and this is now given, the mass is to be so much, so the volume of piece, volume of piece of iron V is equal to M upon D. Now M is given to be 44.5 upon, now D is given to be 8.9 into 10 raised to the power 3. Now this is in gram force. This is in gram force. So convert it into the kilogram force. This will be multiplied by 3. This will cancel. So this is now your 5. This will come out to be 5. Then what is asking? Weight of iron piece in water. Therefore, weight of iron in water. This is equal to the volume of this solid into the with density of this water So this is coming out to be now volume is 5 and density that is equal to 1. This is taken to be what? This is taken to be 1. So now this is equal to 5. So this will give you the loss in weight. This is what? Upthrust यही आना चाहिए इसका. Weight and the weight of iron piece when immersed in so much. Weight W2 equal to so much. So upthrust weight in water is equal to, now this is your W1 minus W2. This W1 is what? This is given to 44.5 minus 5. So this is now your 39.5. This is so much gram force. This is the answer. This is the question number 15 of this chapter, the part 5B of the 9th class of ISC pattern. So all the students have to watch this video completely and write down all the numericals that I have solved here. One numerical is to be left, that is for your practice. So thank you very much.